Okay, so this lesson we're looking at hydraulics, and really to understand these, the first thing we need to do is think back to, I don't know, probably year 7 or year 8 and think about pressure. Okay, so in everyday language you might use pressure in certain circumstances. In science it is basically, very simply, it's a measure of the force of something divided by the area of which the force acts. So P equals F over A. For example, one thing I sometimes think of is a woman with a stiletto shoe. She will create a high pressure, just because even if she's very skinny, very light, she puts all that force on one very small area. On the other hand, something like a tank wouldn't actually exert that much pressure, even though it has a large weight, so hence a large force. It spreads that force out over a very large area. Okay, so that's what we're dealing with. We're dealing with pressure. Okay, so just to illustrate that, so pressure is force divided by area. Pressure is measured in pascals. You might write it as newtons per meter squared as well. Force is measured in newtons, and area is measured in meters squared. Missed that. Now, when we're dealing with hydraulics, we're dealing with putting a force through a liquid, or putting pressure on a liquid. Okay, and the key thing is, like these divers saying, liquids cannot really be compressed. They're virtually incompressible because the particles are already close together. A lot of people think that liquids, the particles, look something like this. In reality, that's not a great diagram. That would be more like a gas state. Okay, so liquids, the particles are still packed together. What they're not in is a regular arrangement. Okay, so because there's virtually no space between the particles, they can't be compressed like, say, a gas can. Okay, so what we can do, if we use a liquid, and probably one of the best examples of this is like something like a hydraulic brake. Okay, we can send forces from one place to another in these hydraulic systems. Okay, all because we can't compress the particles. So if we have something here, let's say we have the brake pedal. Okay, if you put a force on the brake pedal, we can then transmit that through the brake fluid, okay, through a wire through the brake fluid to the brakes which act on the wheels. Top left diagram. Another example might be raising something like this smartly dressed mechanic with a small force, okay, and raising something with a much larger force. I mean, this car would have a much higher weight than this man. So here you can see how a hydraulic system might act. Okay, so we've got two parts called pistons. That's where we apply the force, or where the force comes out of. So we've got piston X and we've got piston Y. We can use these hydraulic systems as force multipliers, and we'll try and show you why now. Okay, so at piston X, the force is 10 newtons and the area is 10 centimeters cubed. So if we want to work out the pressure exerted on the liquid, we do our pressure equals force divided by area. So that would be 10 over 10, which equals 1 Newton per centimetre squared, because the area is in centimetres, not metres. Okay, now that pressure is exerted on the fluid, and that means it acts everywhere in the fluid in all directions. Okay, because remember we said it's incompressible. It also means even over here near piston Y, there is a pressure exerted on piston Y, and that pressure is identical to the pressure exerted from piston X because of these liquids being virtually incompressible. So what we'd need to do, we need to calculate the force applied on piston Y. So if we use our equation, we've got pressure equals force over area. From before, we know our pressure is 1 Newton per centimetre squared. We don't know the force, but we do know the area, which in this case is 40. I've got that from here. Okay, so then I rearrange that, I'll bring that up here, and I get force equals 40 newtons. So you can see this has been used as a force multiplier. We've put in a 10 Newton force, okay, and because this area here is 4 times as big, we've come out with a force 4 times as big, 40 newtons compared to 10 newtons. Okay, so you could use this principle. For example, let's say in a braking system, our feet can only apply a certain force, certainly not enough force to stop a car. If you were trying to stop your car with your feet, just putting your feet on your brakes, you would be very unsuccessful. But if we use a small enough area here in contact with the liquid and a large enough area here, okay, in contact with the brake, then we can have a force multiplier effect and stop the car. Okay, here's another example. Okay, we've got something called our master and our slave pistons. Alright, this again is probably going to be another braking system. This would be the brake fluid, and your brake would actually be here, and then your tyre just coming around, your wheel coming around, and here would be our foot. Okay, there's my nice shoes. So what we need to do again is find the force exerted on this side, okay, on the slave piston, which would then lead to the force exerted on the wheel. Alright, so look at the master, and we've got pressure equals force 30 divided by area 10. Okay, so we're getting 3 newtons per centimetre squared. Just as before, it acts in all directions, and it's the same force, the same pressure throughout. So it acts on our slave piston here. So over here, we'd have a pressure equals force divided by area again. The pressure on this side would be the same, so we'd have 3. We're not sure of the force. We know the area is 30. Okay, again, times both sides by 30 to get it equal, and we've now got a force equals 90 newtons. So again, it's a force multiplier. I mean, you can see another example here. This one, I mean, you can make it easy for yourself. The area is 10 times as big. Okay, so this force will be 10 times as big as this one. So instead of 10 newtons, it'll be 100 newtons. You could maybe do the working out just to check that that's correct.